Okay, so now we're going to get into the proofs and what the derivative of inverse trig functions are. So you can notice that there are several formulas here. You do not have to memorize these. You will always be given these on any test and for your homework. So today we're going to look at the proof of this, and when you're done with this video, I'm going to ask you to upload the proof of the inverse of the tangent to Google Classroom. Okay, so let's get into a proof of um, the inverse sine. Okay, so okay, okay, all right, you can have that. Jackson's here and has a lollipop. So I'm talking on a video. So you can have a lollipop. It's okay. It's okay. You can eat it. All right, so the inverse sine of x. Now, the way trig functions work, or inverse trig functions work, we can switch this and say that the sine of y,
Mommy.
no thank you, Jackson, of y is equal to x. Okay, so now this we're going to be able to take the derivative of using implicit differentiation. So I'm going to take the derivative of both sides. I'm going to take the derivative of this side, and then I'm going to take the derivative of this side here. And when I do that, I'm going to take the derivative of the sine of y, and then I'm going to take the derivative of x. Okay? Well, the derivative of the sine of y is cosine y, but we know we differentiated with respect to x, so we need dy dx. And we know that the derivative of x is 1. So then I'm going to be able to say that dy dx is equal to 1 over your cosine of y. Okay, so we can't stop there. We're going to do a little bit more work.
I don't want this anymore.
Okay, thank you.
I feel hard.
Okay. So from here, what I'm going to do is I'm going to use a trig function, okay? So I'm going to use the fact that the cosine squared of y plus the sine squared of y, we know that that is all equal to 1. And then I also can simplify this. I'm going to find out what cosine y equals. So I can say cosine squared of y is equal to 1 minus the sine squared of y. And then I'm going to take the square root of both sides. So I'm going to say the cosine of y is equal to, now this should be plus or minus, but for this purpose, it's okay to just say it's 1 minus the sine squared of y. Okay, so that is what 1 minus the sine squared of y is. Okay, so now we can go over to here, and I'm going to resubstitute in, and I'm going to say, okay, this is really 1 over the square root of 1 minus the sine squared of y. Okay, now we did say at some point back here, we said that, let's see, I'm going to highlight up here. We said the sine of y was equal to x, okay? So right here, the sine of y is equal to x. So I'm going to resubstitute back in here, and I'm going to say that this is then equal to 1 over the square root of 1 minus x squared. Okay? Now, if we go back to our formula sheet, let's look at what we had here. Okay, so here's what we got. 1 over 1 minus u squared. Now, the chain rule works. And if you take the derivative of u with respect to u, so the chain rule, this can be a function, a composition of functions. So this can be a function within here. So our proof was just for x, but it can be a function within a function. Okay, so that is where the function comes from, or the derivative come from. So if I want to take the derivative of the inverse sine of x, then that's simply 1 over the square root of 1 minus u squared. But we realize that if I take the derivative with respect to u, I need to include du dx. Okay, so that's just a accounting for the chain rule here. Okay, so that is the proof. Okay, I would like you to upload the proof of the inverse tangent. So I'd like you to upload the proof of, figure out how to take the inverse tangent, and you know that the result should be this formula right here. Okay? And in this video, I'm going to do another example. I'm going to do one that's similar, that's number 7 in your book, and it's going to show how to use these this new derivative that we just found. So we're going to take the inverse sine of x plus the square root of 1 minus x squared. Okay, so I'm going to take the derivative of this. So we know that y prime is equal to this. This is a product rule, so I'm going to take x times the derivative of the sine. I'm just going to write derivative of sine because that's going to be a little bit of work here. Okay, plus, all right, product rule is then going to say the inverse sine of x times x, which is 1, plus, now I need to take the derivative of this. So this is going to be 1 minus x squared to the 1/2. Okay, so now in the next step, I'm going to be able to take this. So I know that if I take the derivative of the inverse sine of x, that's going to give me 1 over the square root of 1 minus x squared. And then I've got just inverse sine of x here. Okay, and if I take this, derivative of this is going to give me 1/2 times 1 minus x squared. 1/2 minus 1 is negative 1/2. And then times the derivative of this is negative 2x. Okay. All right, so now I got to clean this up. So I've got x over the square root of 1 minus x squared, plus I have inverse sine of x. Okay, inverse sine of x. And now, let's see, I have a 1/2 and a 2, so that makes a minus. The 2's will cancel. And then I've got an x in the numerator, and this is all in the denominator, so it's 1 minus x squared. Okay, and it's easy to notice that this and this are now going to cancel, and the derivative of this results in the inverse sine of x. Okay, now what I'd like you to do is work through the riddle sheet on, that I have left for you to do in class today, and you'll get some extra practice doing derivative of inverse trig functions. I'm going to do one more video that shows the chain rule, and then you should be good to go.